geometry. So, okay, geometry is all about angles and figuring out what size angles are, etc. Right? Okay. So I'm just going to make a list of a big load of facts. Okay. Right. I have the new facts typed out for you. Okay. And kind of the harder facts that, but all these facts you've learned in junior cert, you know most of them. Okay. Right. Okay. So facts. Right. Okay. Uh, First off, types of angles, right? Okay, if an angle is between 0 and 90, it's called an acute angle, yeah? Right, it's between 0 and 90 degrees. Actually, it's between 0 and 89, right? Okay. So 0 to 89 acute angle, right? Okay, then if it is exactly 90, it's called a right angle. Okay, if it's an obtuse angle, these are all words you've heard before, yeah? Right, obtuse angle is between 91 up to 179. Actually, that's weird. So I might say greater than 90, less than 180. Okay, that's an obtuse angle, right? Okay, a straight angle, straight line, angles in a straight line add to 180 degrees. So straight angle, um, then if we go greater than 180, it's a reflex angle. Right, greater than 180, less than 360. Right, okay, and finally, a full circle, 360 degrees. Yeah, is it okay if I do that, if I cut anyone off? So if you have a full circle, 360 degrees. Actually, you know the way I put facts there, I might just put angles underneath that. So facts about angles. I have more. Right, if we have three angles, right, okay, that make up a straight line, so A plus B plus C will add to 180. So if a load of angles make up a straight line, they add up to 180. Okay. If a load of angles make up a full circle, so I'll go A, B, C, D, and E. So A plus B plus C plus D plus E will give me 360 degrees. Right, if you have an X, right, vertically opposite, that you make vertically opposite angles. So it has to be a full on X. It can't be something like, that's not a full on X. It has to be an X, right? It can't be like that. Okay, vertically opposite angles are equal. So you did all this in junior cert, but you haven't probably heard about it since, so. So if I say 1, 2, 3, 4, so angle 1 equals angle 3, and angle 2 equals angle 4. So vertically opposite, the ones straight across from each other, are equal, and you have to have an X. So I'm just going to put an X in brackets there. There has to be a full on X. And don't forget, 1 and 2 make a straight line. So what do 1 and 2 add to? 180. And 1 and 4 will add to 180. And 3 and 4 will add to 180. And 2 will 3 will add to 180. Don't forget your straight lines. Is that okay? Right. Okay. Right, then if we have two parallel lines, and a line crossing them is called a transversal. Right, okay. Right, corresponding angles are equal. Corresponding angles, girls, are if you make an F. Now the F can be backwards, upside down, slanty, so corresponding angles, and I'm going to put the letter F in brackets, are equal. So the two angles inside the F are equal, okay? So if you can do an F, this angle and this angle are equal. Is that okay? So the two angles within the F, okay? So you can do lots of different Fs here. You can do backwards Fs, upside down Fs, etc. Okay, so I'll get a few colours going. Okay, so look, here's an F. So that there and that angle there are equal. Agreed? I could do a backwards F. There's a backwards F. So that means that angle there and that angle there are equal. Right? I could do an upside down F. Right? So I'm going to do an upside down F. So that means that angle there and that angle there are equal. Okay, and so on. There's a one more F there I could do. Okay, but I've only got 3 colours and it's getting messy anyway. Okay, are we all right with that? F is a corresponding angle. Right? Okay. Can I go? Am I okay? Right, okay, what's the other letter? Do you remember from junior cert what the other letter is? A Z? Right, okay. And so again, you have your two parallel lines and a transversal, right? And the Z is alternate angles. right? And I'm going to put a Z in brackets there. So alternate angles are equal. Again, you could do backwards, forwards, weird looking Z's or whatever. All you have to do is just get a Z. So look, the straightforward Z is this one here, look, Z. So inside the Z, the two angles inside the Z are equal. Right, okay. I could also do a weird looking Z, right, okay. I think there's a Z there, see the way it's kind of, that still counts as a Z, okay. It's a weird looking Z, but it still counts as a Z. Is that alright? Okay, and they're alternate angles. And the last thing is interior angles. So interior angles add to 180. Okay, so interior, by interior they're both inside the parallel lines. Okay, so they're in between the parallel lines and they're on the same side as the transversal. So A and B, so A plus B will add to 180 degrees. Right, and then I could have C and D. Excuse me, please, remind. C plus D will also add to 180 degrees. Okay, and what all that means is, right, you needn't bother writing this bit down, right, but this is just me. What it means is, if you have two parallel lines and a transversal, right, and they give you one angle, so tell me, just say, they tell me one angle is 110 degrees. It means you can get all 8 angles, 1, 2, 3, 4, 5, 6, 7, 8. It means you can get all 8 angles there straight away, right? Okay, look, I could do a Z. So that means that one over here would be 110. There's an X here, so that means vertically opposite 110. These two make a straight line, so that would mean they add to 180, so that means this one here is 70. Vertically opposite is 70. To figure out this one is 70, you could use the F, or you could use the interior angle to add to 180, so that's 70. Straight across from that's 110, and straight across from that is 70. Is that right? So once they give you one angle, you can get all 8 angles. Is that fair enough? And to be honest, you get away with the just knowing the Z one, right? Okay, I think if you know the Z one, you know them all. As in, you can get by without using the rest of them. Is that right? Okay. Are we good with that? Right, okay. Will I keep moving? Yeah, okay. Right, so I'm on to facts about triangles next. So facts, we're still on facts, but this time they're going to be about triangles. Right, the most important fact you need to know about a triangle, and we've used it already in trigonometry, right? What am I going to say? Angle A plus angle B plus angle C will be added to, when you add the three of them, what you get? 180. The three angles in a triangle add to 180, right? Most important fact, okay? And we've used that when we did trigonometry. We've used it, okay? Right? Exterior angle, which you'll get away without knowing, right? So if I call this A, this is angle B, this is angle C, and I made a new angle D by just extending one of the sides, right? That's called an exterior angle. Exterior means outside, so it's outside the triangle. So the exterior angle, the angle D, is equal to the sum of the two interior opposite angles. So angle D is A and B added together. Okay, and you needn't do this bit, but what if I did this? 1, 2, 3, 4. What would 1 be equal to? Which two added together would give me 1? 3 and 4, right? Okay, what if I did it this way? 1, 2, 3, 4. What would 1 be equal to? 3 and 4 again. So 1 would be equal to 3 and 4 together. For example, if 3 measured 30 and 4 measured 65, that means 1 would be 30 plus 65, which would be 95. Is that right? But you can get away without knowing that fact, because you could get the third angle, because 3 angles add to 180, and then 1 and 2 make a straight line. So you can just go a longer way about getting it, but I always forget about that fact. Right, I use the other ones. Right, okay, but anyway, there, I told you what anyway. Is that right? Okay. Then types of triangles, girls. If all 3 sides, oh, that was desperate. Right, okay, if all 3 sides of an equilateral or a triangle are equal, right, so they'll put the same kind of symbol on each side. See the way that means all those 3 lines are equal. What's that mean? It's an equilateral triangle. An equilateral triangle, and that means 3 equal sides, 3 equal angles. And I can go one step further, right? So 3 equal sides, 3 equal angles. What can I say? If the 3 angles are equal, what must the angles be? They have to be what? They have to add to 180, and they're all equal. They'd have to be 60. So in an equilateral triangle, you know what sides the triangle or the angles are. They're all 60. Is that okay? So that's the only triangle where you know the angles. You know the angles without them telling you. Right, can I move on? Right, the next one is, next type of triangle is this one. So again, they'll put the same symbol on the lines. What kind of a triangle is that? Isosceles triangle. And an isosceles triangle has how many equal sides? 2 equal sides, and therefore 2 equal angles. And the 2 equal angles, girls, are not the ones between the 2 sides. Okay, so when you're trying to figure out which are the 2 equal angles, right, it's not the one, so that's one of the equal sides, that's the other equal side. It's not the one that the 2 equal sides make. So angle A equals angle C. Okay, don't write down the next bit, this is just me So if I said they were your equal sides, 1, 2, 3, which are the equal angles? Don't write this one down. Which are the equal angles? 2 and 3. It's not 1, because 1 is made by the 2 equal, right? Okay. Which are the 2 equal angles here? 1 and 2. So it's not the one between the 2 equal sides. Okay? Just one more. Which are the 2 equal angles? 1 and 2. Right? Got it? Because it won't be straightforward like this if they give you one. They'll make them look funny. Right? Are we good? So it's not the angle between the 2 equal sides. So there's the 2 equal sides, it's not that angle. There's the 2 equal sides, so it's not 3. Right? There's the 2 equal sides, so again it's not 3. Is that okay? Right, do you know what a triangle with no equal sides and no equal angles is called? Scalene. So a scalene triangle has 0 equal sides and therefore 0 equal angles. And then we'll do finally a right angle triangle, right? And a right angle triangle has a right angle in it. And remember, the hypotenuse is straight opposite, so the hypotenuse squared is equal to a squared plus b squared. And remember, if you have a right angle triangle, you can also use SOHCAHTOA. See, we just finished trigonometry. Okay? So right angle triangles, if they tell you it's a right angle, it gives us lots of options. We can use Pythagoras' theorem, we can use SOHCAHTOA. Okay. Right? And finally, by the way, this is all your junior cert geometry, I'd say, in one class. Okay? Right? Okay, finally, I need to talk about congruent triangles. Do you remember congruent triangles? What does congruent triangles mean? The triangles are the same. The same. Everything about them is the same. Congruent triangles. Right, and I'll just put the same. So they're exactly the same. So if you're trying to prove that if these two triangles are exactly the same, okay, there's 6 measurements in a triangle, isn't there? Where am I getting 6 measurements? There's 6 measurements in this triangle, isn't there? There's a measurement of 3 angles and there's a measurement of 3 sides, yeah? Would you agree? So there's 6 measurements in a triangle, right? So what the next 3 conditions are, right, is if I was trying to prove those triangles were the same, would I have to prove all 6 things are the same? No, there's a shortcut, okay, right? So if the shortcuts are SSS, SAS, or ASA, or if it's a right angle triangle, we have RHS. Okay, so rather than saying all 6 things, I have to go through all 6 things, as in this line equals this line equals this line equals this angle equals this angle equals this angle, this angle equals this angle, right? Okay, that's a lot of work, trying to prove all 6 things are the same. So what these 4 conditions are shortcuts, right? Okay, so SSS stands for side, side, side. So if I can prove that that side equals that side equals that side, and that side equals that side, I don't need to measure any angles, right? I don't need to talk about any angles, because everything has to be the same then, right? So I don't, if I can say that all 3 sides are the same, I can say all 3 angles are the same, right? Is that okay? Right, what do you think this stands for? Side, angle, side. Angle, side. Now this one is the only one that has a little extra condition attached to it. So the angle you pick must be between the 2 sides. Angle must be between the 2 sides. So again, if I was trying to prove these triangles were the same, were congruent, I could say, well, if I can say that maybe that line equals that line, and I can say that the length of that line is equal to the length of that line, and then I say, oh, this angle here measures the same as this angle here. I have side, angle, side, and the angle is between the two equal sides, isn't it? It's between them, isn't it? So therefore that's another shortcut. So if I can prove that much, just those 3 measurements, the triangles have to be the same. What if I said though, right, that side equals that side equals that side, right, okay, and this angle over here equals this angle over here. Are those triangles exactly the same? Maybe, maybe not. I don't know. I can't prove it with just that much information, because the angle has to be between the 2 equal sides. So the angle has to be there. So if they told me a different angle, those triangles may or may not be the same. I don't have enough information. Is that okay? Right? Okay. The next one, the next shortcut is angle, side, angle. So girls, it can be, the side doesn't have to be between the 2 angles. It can be any 2 angles, any one side, right? So, I have a duster. I don't need to do that. So if I have a triangle and I have another triangle and I'm trying to prove they're the same, and I measure this line, it's equal to the measurement of this line. I measure this line and it's equal to the measurement of this line, right? And I measure, sorry, it's 2 angles and a side, isn't it? So if I measure that side, I measure one side and I measure this angle, and I say it's equal to this angle, and then I measure this angle up here and I say it's equal to that angle over there, I can say those triangles are exactly the same. So I have an angle, a side, and an angle, right? And this doesn't have a condition like the other one. You know the way the angle had to be between the 2 equal sides? This one, no, it's any 2 angles and any one side. Is that right? So if I can prove any 2 angles and any one side are the same, I can say those triangles are exactly the same. Yeah? And finally, the last one, girls, applies to right angle triangles only. So if I can say RHS stands for the right angle, H stands for the hypotenuse, and S stands for any other side. So this is just a special one for right angle triangles. So if I have a triangle and I have another one over here, and I say that right angle is equal to that right angle, the hypotenuse is the line straight opposite, so I'll say that line is equal to that line, and then any other side, so that line is equal to that line, right? Okay, so I have a right angle, the hypotenuse, right, and any other side, and once I can say that, I can say those triangles are exactly the same. Is that right? Okay, so it's just 4 shortcuts for saying the triangles are exactly the same, so I don't have to do all 6 measurements, right? So the 6 measurements in this, 6 measurements in this, I don't need to do out all 6. I can just do any of these 3, and if I do any of these 3, I can say everything else has to be the same. If any of these 3 are equal, then all 6 have to be equal. Is that alright? Okay. So I'm going to give you a little break, and then when you come back, you're going to do questions on all of these. Okay? So I'll see you back here in 5 minutes. Well,